Hey, everybody. Y'all doing okay? Great. My name is Jurnell Cockhren. Thanks for coming to my talk. This talk is about how to write code to induce social change. A very big problem. But I think together we can figure this out. We can do that today. So I'm not really good at the whole introduction thing. I don't really want to talk about myself. It's not about me, but just a little bit. I am what is called a civic hacker. I'm the founder of Software, a civic tech company based in Nashville. I'm the co-founder of Black in Tech Nashville, and I'm the senior infrastructure engineer of Concert Genetics. So usually people get up here and talk a lot about what they do on the day jobs, but I'm just going to give you a quick overview just in case you didn't read the bio because it's long or whatever. So I started in optics, neuroscience, astronomy, mathematics. I go to all the best conferences, I have all the jobs, and I write all the code, basically. And kind of sum it up, I'm an impatient millennial. I want my freedom from oppression right now, while I have the youth to enjoy it. Okay, so today's goals. We definitely want to examine inequality in society with a technical lens. We want to model the solution. And I want to coerce everyone here into being civic hackers as well. And we're going to have a little fun and nerd out a little bit. That's the reason why I'm here at Strange Loop, to fully just spread these wings right quick. OK, let's start. Civic hacking. So that means, centrally, we want to protect the citizens from the government, sometimes. Sometimes the government does things that are not in our best interest, and we got to kind of have a backup plan. We want to help and upgrade the government. Consider the government as a system that is upgradable, meaning that due to our involvement, our civic engagement, we're able to patch bugs in that government system. We want to enhance societal systems and well as patch those societal systems as well. And today we're going to talk about patching a societal system. So before we really get into it, just know that there's going to be some regular text that's going to talk about some practical meanings. There's going to be some things in blue. There's going to be some very mathy things for the math heads here. And then there's going to be some things in thought bubbles, because why not, of course. So hashtag inequality in society. Inequality is a bug in American society, in my opinion. It is what I call a hard problem. And we're going to define what it means for it to be a hard problem. It affects thousands, and it is not a technical problem. Yes, this is a technical conference. Yes, I'm a technical-minded individual. And yes, we are going to use some technical tools to help make this solution to that problem a little bit easier. Okay? So as a review, hopefully this is a review. Hashtag inequality is when we have one set that's like, man, why is this system so broken? And then we have another set that says, well, the system works on my machine. And that differencing of user experience is in itself not the problem. The problem is the next step, is that there's little to no effort to reconcile the differences of user experience. Imagine that. You have users in Chrome who have one great experience, and users in Firefox that have not so great experience. And then what if all companies was like, meh, that would be sucky. So we want our systems, our societal systems, our government systems to be able to reconcile those differences of user experiences. Now, that kind of makes me sad that this reality exists. I'm sure not everyone may not feel sad, but hey, some of us, hopefully. But what makes this problem so hard? Right? We know it exists. You're either a victim of it or a witness of it. So here are our blockers, the emotions of decision makers. So decision makers are anyone that hires someone, who influences policy, who can make a decision that could lead to that split of user experience. Anybody. So all levels of society, these decision makers exist. And those emotions are the blockers because sometimes the fact that you have to consider there's a different user experience for a different subset of population may trigger you. You may be like, I'm not a nasty person. Why do I have to think more about this group that's not so privileged? And that idea, that thought process may be triggering. Then there's the unconscious bias, something that we don't have control over. We're just trained. And then there's the lack of direction. Given that the scope of this problem is so large, like, where do you even start? It's so daunting. So those are our blockers, and we're going to release those blockers today. So in order to do that, we essentially need a series of decisions made in the right direction. So I'm not going to enforce there has to be, that we agree on what those directions may be. I'm not going to enforce what the decision should be, but I'm going to say that we just need those decisions to happen in all those different directions. Different forms of equality require different decisions at different points. Okay? And this is what is called a decision problem. I'm scoping it as a decision problem, hopefully to make it easier for us technologists. So our intuition, #intuition, tells us that technology could help us address inequality and other societal problems. That's just our feels. But our feels doesn't solve problems. It's a start. It may motivate us, but in itself doesn't really do anything. #hypothesis. So modern technology enables oppressed populations to verify solutions of instances of inequality in reasonable time. And the in reasonable time part is very important because that means that we can get an answer pretty quickly. And I feel that the masses can build the tech. We have an entire internet mostly running on open source software. I think we can build something that could help solve this problem. I think it's within our wheelhouse. And I can't do it by myself. I wish I could, but I really need your help. So let's collaborate. It's going to take combinations of data and effort. So there are many instances of inequality. If we consider inequality in society as a class, then there are multiple instances of #inequality. For example, there are disparities in treatment by police, right? This is a review. Digital access. Not everyone has internet access. Not everyone can afford internet access. Not everyone lives in a place where there are service providers. That is a disparity. And income disparity. Based upon your gender and race and ethnicity, you may get paid differently. As soon as you sign that offer letter, they've lied to you. Sorry. Okay, we're going to use the variables t, a, and y to represent the effort to correct the disparity. That's what we're going to do here for the math heads. So income disparity. So this visualization is from informationisbeautiful.net. It displays the gender pay gap in the United States. And those two areas, if you can really see that, that light text, is the disparity between across gender when it comes to senior executives as well as technologists. It's pretty huge. It's large. This data is from 2015. Why? This doesn't make sense. Right? We can count. We have machines that can count. Why we have this problem. So the effort to fix this is called variable y. So the right effort, with the right effort, oppressed populations will be able to answer yes to, has income disparity been minimized? This is, again, framing this as a decision problem. And yes has to be given in reasonable time, meaning that it can't take the rest of my lifetime for us to just check the answer. Not to create the answer or present the solution, but just to check the previously provided solution. We just be able to check our work fast, okay? So how will we know if our efforts worked? Us being able to check whether or not our efforts has worked pretty quickly allows us to iterate quickly. That's the reason why testing is important in software. If your continuous integration system is able to run your tests quickly, then you're able to iterate faster, being able to check whether or not your efforts on the job has worked. And that brings us to NP complexity, where decision problems, where there are yes answers, can be verified in what is called a computationally deterministic manner. Okay? They like those words. Computer scientists love those words with all those syllables. But it really means that we can just check our code, check our work quickly with code. That's really all that means. And here's the formal hypothesis, is that all instances of inequality in society are in the set of NP problems. Yeah, I said it. And we're going to walk through a light proof of that instances in society are in the set NP. We're going to do that together. Okay? So I'm going to pick one, income disparity. Who wants to see a solution for income disparity? Look at all those hands. All right, let's do it. I'm up for the challenge. So models matter. My background in physics have taught me that physicists really are awesome because they're really good at building models. Like, you don't have an idea of what you're really dealing with, but you kind of can like draw a picture or kind of like, scope out the behavior a little bit so that you can kind of guess what it kind of works on the inside, how it works on the inside. So the act of building models and testing against those models you've created is definitely a unique skill of physicists. They're awesome in that way. So our model is that I'm going to say that distributed effort we're going to use distributed effort to verify the solutions of minimizing income disparity. Okay? That's our model. I'm not saying it works. I'm just saying that's where we're starting. This is our starting point. So in order to do that, we're going to have some tools. I'm going to pull some things out my toolbox. First is human empathy. We got that, right? We got that, right? At least some of us. I'm going to use the complex plane. It's one of my favorite tools for mathematics. We're going to use the geographic coordinate system. We're going to call that G, that very special squiggly G. We're going to have code/policy. The reason why I say policy on that bullet point is because policy is a form of code. Okay? We can see that. It's not too far-fetched. And we're going to have crowdsourced data, so data from everybody. We already give our data to billion-dollar companies all the time for free. We can give a little bit more towards solving a problem. I think we can. So that's all we need here. So yes, first coordinate system, the geographic coordinate system. Because why? Humans live on Earth, right? Just sanity check. We got a sanity check. We can't have too many large leaps here. Then the complex plane, if you remember this from any of your math classes, if you took those math classes, we're also going to have that. And we're going to use a tool, a very special tool, one of my favorites from mathematics called the Riemann Sphere. The Riemann Sphere allows us to centrally map the GPS coordinates to the complex plane. We all remember what functions are, right? In the mathematical sense, functions require a set of inputs that map to a set of outputs. Now, how we do that mapping can be algorithmically, or it could be with a plain old table. Both are mappings. Both demonstrate functions. Okay? And of course, in computer science, that function would have a function signature, right? Okay. And so for the math heads, we're just defining a mapping. So that's what that is. That's all the function is. We're mapping from one coordinate system to the other. And that equation at the bottom is what we're doing, taking two inputs of longitude and latitude, and creating a complex number. Now, all that really means is that we can just wrap the Earth in the complex plane, kind of like just wrapping a present, where the top of the Earth, the North Pole, is like infinity. So we're just wrapping it. That's the best graphic I could find, but that's the only graphic I could find. So hey, there it is. And that really means we can draw lines. This is so important. Mathematicians love drawing lines, specifically things called boundaries. That is a very important concept in mathematics. And the fact that we can draw these lines on the Earth's surface means that the complex plane is dense on the Earth. Now, density is a technical term in mathematics. It's also a technical term in physics, not the same meaning. Same word, different meanings, okay? Density in mathematics means that for any two geographical points on the Earth, no matter if we're talking about between St. Louis or Nashville, or between myself, this stage, and that door, there's always going to be a complex number in between those 2 points. That's what my mapping does. So for any points on the Earth, there's always a complex number in between them, okay? There's density. That's Gucci. That's Gucci. Now remember, humans live on the Earth for now, and sometimes in cities. And that means that we can draw on the Earth closed paths. This map is an outline of Davidson County. Davidson County is the exact same boundary of the city of Nashville. That's not true for every city. A good example where that's not true is Memphis, where the city boundary of Memphis is not the same thing as the boundary of Shelby County. But for some cities, this is the case. It's called a consolidated boundary by census. Okay? So we can call these closed paths. These closed paths are very, very awesome in the complex plane. They'll allow you to do a lot of things because you can draw a line and there'll be no gaps. So where our effort goes. Everyone, including the oppressed group, must be able to submit data. Okay? And then one person, at least one person, builds a chart. Yes, the slide says one person, but we just need at least one person. Build a chart. That's it. Using D3 or whatever you want, it's fine. This is where our effort as technologists and citizens go. Now you have a small target, smaller target. Simple charts are deterministic. They can be calculated in a reasonable time, even with very, very large data sets, even with data sets that change every second. Their results are deterministic. Therefore, income disparity is in the set of P. Thus, it is proven. Done. So recap. That was easy, right? That was easy. All we have to do is just make sure that we provide code and data for this problem. We examined inequality through a technical lens. We acknowledge ever so slightly that social problems may require technical work and non-technical work, right? We know that. We did some maths, and we did our proof. Y'all buying it so far? Yeah, it's gravy. It's real easy. It's a hard problem, hard. But wait. Income disparity does not equal all of inequality in society. So how can I even say this is done? Yes, I did one proof for income disparity specifically. But boundaries matter. Okay? So all that allows us is saying that any closed boundary, any city, county, contains a set of instances of inequality. Every city has an instance of income disparity. Every city has an instance of disparity in treatment by the police. Every city in rural area and county, inside of it has an instance of disparities in digital access. Those sets exist within those closed boundaries. So I'm evoking the axiom of choice. So if you don't know what the axiom of choice is, that's fine. For those who question my use of the axiom of choice, I'm going to explain it to you. And if you want me to go in depth after the talk, cool. Yeah, just meet me in the hallway somewhere around the coffee. Works out. So that means I can pick all the instances of inequality in any set, in any city, in any closed boundary, in any order that I want, starting with income disparity. Boom. That's Gucci. What? There is a choosing function. That choosing function is based upon maybe whatever arbitrary thing that I pick. I'm just do all of them. I'm just starting with income disparity. Maybe because for me it may be the simplest to solve. But what about the other types of effort that will need to be given when it comes to other instances of inequality? We can't use the same effort for income disparity that we would use for disparity around treatment by police or by digital access. Well, in those cases, I can just tell you what we would do, okay? So when it comes to treatment by police, right, we'll first need to have an understanding of the routes of the police. Second, we'll have to know where are the location of the precincts, okay? And third, we'll have to have an idea based upon what police officers interacted with which individuals that led to death. So that may give us an idea of which precincts to focus our efforts. Because across any city, including, St. Louis, every precinct is not behaving in the exact same manner or providing the exact same statistics around treatment of people of color. So we might need to target our efforts a little bit. That data that we can crowdsource tells us where to put our non-technical effort. We might need to go talk to the police chief of a certain place, of a certain sergeant in a certain precinct, not all of them, okay? When it comes to digital access, we care about what internet providers are there, where are the location or the distribution of population in a city, right? We know that there are metropolitan areas, but we know that people live outside of metropolitan areas as well. So the density of population matters. Also, the backbone or fiber backbone matters. What also matters is the policy that is used to even deliver the services. For example, in Nashville, Google Fiber wanted to come. They're still coming. It's been a long time coming, still coming. And, telephone poles is how you send information. It's how you send, data. But, they have to put things on the poles, and everybody just can't do that. There's laws around that. So yeah, so those parameters are city-specific, or I can say boundary-specific, because it's not just cities. So boundary-specific rules determine where our effort should go if we crowdsource this data. A lot of this data being either provided by you all or provided by your local governments through open data. Yes, that is Gucci. And so we have ways to say, regardless of what order of instances of inequality that I pick or you pick, that everybody can pick an instance of inequality. They can all be different instances, and to provide an effort towards solving that problem. So we know where to place our efforts, right, depending on the problem that you care about. Now, this leverages hard on how open source development is successful. It's a collaborative effort. Not everyone cares that much about the Linux kernel. Sorry, not everyone's submitting code to the Linux kernel. Some people are submitting code to JavaScript. Some people are. Some people are writing React, fine. But we care at different levels. Some people are not able to commit core code. Some people willing to write documentation. Some people are willing to just find the bugs, just find them. Some people are just willing to thumbs up the bugs, Oh, that's important. Give me a +1 if that's really a bug, that helps. So everybody cares in different magnitudes about different things. And the aggregate effect gets us to change if we are directional or if we are intentional with our use of our data and effort. So I think everyone in here can be a civic hacker. Everyone outside of this room can also be a civic hacker. Everyone in the whole wide world can be a civic hacker. Yes, even grandma. Yeah. And we have a way to check our work quickly. We can iterate on this fast. A homework for the class is, how do I write a unit test for this? But that's not today, next time. So I don't really, I'm not sure. I'm not sure if this is any of this will work. But why not? Thank you.